All right, so here's part 2. All right, so we're looking at our axis. I've had trouble with this sometimes too. I found a really simple and easy way to do it. Okay, so these are our degrees, and this is where each lead is looking at. So we've got our AVL, which points off to negative 30 degrees. So if you think about this as me on my chest, the AVL is pointing up towards my left shoulder. The AVR is the exact opposite. It goes up to my right shoulder, so it's going to be negative 150 degrees. Anything up north of this line is going to be negative. Anything down south is going to be positive. Okay. Lead 2 is at plus 60 degrees, and lead 3 is the exact opposite of that at 120 degrees. AVF is going straight up and down, and it is going to be at 90 degrees, and then lead 1 is at 0 degrees. That's just back and forth, okay? So what's my way of determining this? There's a couple different ways. There's a lot of different ways actually that you can do it. It's pretty esoteric. It's kind of one of those ideas that's way out there. You can do it in multiple different ways. You gotta find what works for you. But the way I like to do it right now, and I find really works for me well, determining the axis precisely, because Ferg likes to do it precisely, or wants to know it, the exact one, is to plot AVF and lead 1 net deflection on a graph, okay? So this is kind of a little bit difficult to think about until you actually do it, and then you're gonna be like, wow, why wasn't I doing it the whole time? Okay, so let's say that we have two leads right here, AVF and lead 1. So these are our 0 degree and our 90 degree axes respectively. Let's look at the complex here. The only thing we're going to pay attention to is our QRS complex. Imagine these small lines, the small lines are behind here. We're going to look at the R and the S wave of our QRS complex. Now we got an R, an up, and we're going to count how many up little tiny boxes we go up from the isoelectric line. So let's say this one is 7 up from our isoelectric line. We have 7 little boxes behind it, and it tops off about right there. Now we're going to count down from the isoelectric line. Let's say we have 3 little boxes. Okay, so right there. So we're going to subtract those 2 from each other to get the net deflection of where it's going. So 7 minus 3 is 4. Okay, so we've got a vector of going 4 up. Okay, so we subtract the 2. AVF, we're going to come over and do the same thing. This doesn't really have much of a going down. It's got maybe one little box going down, but it's a very tall R wave. So we go 15 up. I didn't put one in here. I should have said this was a little bit negative 1. This was about 16 up, and then this is 1 down. So we would do 16 minus 1 equals 15. All right. Now we're going to imagine we're going to go back to 5th grade or 6th grade or 7th grade, whenever you learn this stuff. God, it's been so long. And we're going to pull out our graph paper. We're going to plot these points just like a slope on a graph. Okay. So we're going to take lead 1, and we know that lead 1 runs on this axis, right? We're going to plot this like a graph point on this axis. So we're going to go to positive 4. We know that this way is positive on this line, okay? So if we were to get a negative deflection, we would be going this way. If we were to getting a positive deflection, if the number was positive, which it is, it's going to be over here, okay? So we're going to go over to positive 4 and plot that on the graph. Then we're going to take our coordinates from AVF, which is positive 15. So since it's positive, it's down here. If it was negative, it'd be up here at negative 15. So this would be negative 4. This would be negative 15 up here. We're going to plot that point in too. Okay? Now we're going to get a point where they intersect right here. And we're going to have a line. Okay? So if anybody's taking trigonometry around here, we can figure out the angle in a triangle with a formula and get our actual respective axis in exact degrees. So what's the way you do that? The way you do it is you take the tangent, the negative tangent, so put second in here, negative tangent of 15. So our run of this over 4. You're going to get 75 degrees. So our angle right here we just solved for is 75 degrees. Simple enough, right? And if we wanted to check that, we could easily do that by finding our isoelectric line, going 90 degrees from that, and seeing if it is, or going 90 degrees from our isoelectric line and seeing where it's at, okay? All right, so that's that. I think that is the absolute best way to do it now. It's the most precise way to do it, and it's easy if you just count the boxes, okay? It takes a little bit longer, but it also gives you the precise angle that you're looking for. Now we've got hypertrophy, okay? So hypertrophy is another interesting idea. So we've got atrial hypertrophy, okay? So here you're gonna look for, in leads 2 and V1, a greater than 2.5 millimeters tall P wave. And if you get that in leads V1 and 2, you're going to have atrial hypertrophy, okay? And if you have a left atrial hypertrophy, you're going to get a prolonged P interval in leads 2, and they're going to be biphasic in V1, okay? Okay, so right ventricular hypertrophy, I think these are where the money's at. I think this is going to be a test question. We're going to have a right axis deviation normally, and then we're going to have a progression of waves in V1 through V6 that are backwards. So normally we're going to be getting a progression of waves like this through our precordial leads. We're going to have V1. V1, it sits right up here. So where is the electricity going to from the heart if we've got a normal axis? It's normally going to be going down and away from those leads, right? So V1 is mostly negative. It's going to have a little bit positive, but it's normally going to be mostly negative. And that trend, the trend is going to be that we're going to have a little bit more positive with each lead we go across the chest. So this one might have a little bit more. Okay? And then when we get to V6, it's going to be completely almost positive because it's over here, it's sitting right next to the left ventricle, and that's the way our typical progression or our axis of electricity goes to. With left or right ventricular hypertrophy, that is going to be reversed, okay? So we're going to have a mostly positive R wave progression in V1, and it is going to get progressively more negative in our as we go across the chest leads, okay? So that's the way to tell that. Left ventricular hypertrophy is much, much easier to tell. You're going to take the R wave in V5 or V6, and you're going to add it to the S wave in V1 and V2. And if they are together more than 35 millimeters in height, then you're going to have the criteria for left ventricular hypertrophy. So what's that mean? So if we have an R wave, it goes way up. Excuse me. And then we've got an S, so we go way down. Or excuse me, you got an R way down. We're going to measure these from the isoelectric line up to the peak. We're going to add those two together. If it's greater than 35 millimeters, we've got left ventricular hypertrophy. Okay? Simple enough, right? All right, so what else do I have to talk about here? I don't think I have anything more to talk about. I'm going to do a quick video tonight over infarction. Then we're going to do the rhythms. And then I just wanted to touch on the thing again about what order we go in to read. So 1, we got to determine the rate. Rate gives us clues about the rhythm. From the rhythm, we also have to interpret the blocks, so whether there is an SA node block, an AV node block, a bundle branch block, or a fascicular block. 4 blocks we got to read for. 3, we got to determine the axis, okay? We can do that with the tangent method and plotting it on a graph. 4, we got to look at our hypertrophies, so we can either have atrial or ventricular hypertrophies. And then 5, we got to look for infarction. So I'm going to get to that in the next video, okay? I hope you guys enjoyed this. Thanks for watching. I hope it was somewhat helpful. I think a few of my areas here were kind of lackluster, so hopefully it helps somebody. All right? Thank you.